Let us solve this problem in a very simple manner so that everyone can understand. The question says a man travels to work at 2/5 of his usual speed. The time taken by him is what percentage of the usual time taken? These are the options to choose from. So we are given this question that a man traveled at a reduced speed compared to his usual speed. Now we want to look at the time it takes the man as a percentage of his usual time. Let's sort out parameters while we solve the problem. First, let us assume that the usual speed of the man, u1, is equal to x. We don't know the usual speed. But we are told that his new speed is now 2/5 of his usual speed. So we can say the new speed, u2, is equals to 2/5 of its usual speed, x, because we said let the usual speed be x. The man travels to work. Let's assume that the distance to work equals s. Let the distance be s. Now we've sorted out useful parameters, let us dive right into the problem. We know the usual speed of the man, we know the distance, we know the new speed. Let us now calculate the usual time and the new time taken by the man. Remember, the formula for speed is equals to distance all over time. So we can say that the usual time, which is the time taken t1, equals to distance all over speed. Recall that speed is equal to distance over time. So if we make time subject of formula, we can say time is equals to distance over speed. So if we take the usual speed to be u1, we are equally taking the usual time to be t1, and the time is the distance s divided by the speed u1. The distance is s, the speed u1, we said let it be x, so we replace it by x or with x. Now let's calculate the new time t2. If the new speed is u2, we say the new time is t2. T2 will be equal to the distance. Remember, it's the same distance we are talking about. S all over the speed, the new speed, u2. u2. Remember, the new speed is 2/5 of x. So we have distance x all over 2x over 5. 2/5 of x is simply 2x over 5. Now we have a number divided by a fraction. And in mathematics, when you have a number divided by a fraction, the denominator of the fraction multiplies that number and everything is divided by the numerator of the fraction. What I mean is that t2 automatically becomes 5, the denominator, multiplying the number x, 5x, and everything is over the numerator, 2x. S divided by 2x over 5 will give us 5x all over 2x. So this is the new time, t2. Back to the question. The question says, what is the percentage of the new time to the usual time? We are looking at the percentage of the new time to the usual time, t2. In other words, we are looking for the percentage of the new time, t2, over the usual time, t1, multiplied by 100. If we put the values, t2 is 5x divided by 2x, 5x all over 2x, all over t1 all over is division. t1 is x all over x, and that is s all over x multiplied by 100. Remember, it is percentage, so we have to multiply by 100. Again, if we change this division to multiplication, what happens? The denominator comes up and the numerator goes below. So changing it to multiplication, we now have 5s all over 2x times x all over s times 100%. Let's go to the new page. So this is what we have, percentage of the new time, 5s all over 2x times x all over s times 100%. This s can cancel this s, and this x can cancel this x. So we'll be left with 5 all over 2. So the percentage of the new time is equal to 5 all over 2 times 100. 100 divided by 2 is 50. 50 times 5 is definitely 250. So the percentage of the new time is 250% of the usual time. So the answer to this question is option C. Very simple and straightforward, and I believe you enjoyed it. If you did, answer the simple one. Read the question, get an answer, and put it in the comment section, and I will be there waiting for you. Thank you for watching this video, and see you in our next video.